In this example, we want to reflect the function f of x equals 2x minus 6 across the x-axis. You could begin by first graphing the function f of x. So let's take the function f of x in blue. The function f of x is equal to 2x minus 6. And you might recognize this as the general form of the line y equals mx plus b. And so you might recognize that this is going to be a line where the y-intercept is going to be at the point, you know that the x-coordinate is 0 and the y-coordinate is -6. You only need 2 points on the line. So up here at 0, 0, -6, sorry, down here at 0, -6, you have a point. So let's erase that point. So we have 1 point. We need 1 more point. We can use the slope. The slope of this line, the slope of our line, or the m value, is 2. So it is a run of 1 and a rise of 2. So from the point that we have, we would run over 1 and rise up 2. Run over 1 and rise up 2. Run over 1 and rise up 2. And so your curve looks something like that, or your line looks something like that. So we could even go a little farther if we wanted. Run 1, go up 2, run 1, go up 2. And this is the line that we're going to reflect across the x-axis. So we'll do the reflection in red. And we can remember the rule for reflection across the x-axis. Remember, we're just going to keep the x the same and change the sign of the y-coordinate. So this is what the reflected point will look like. So if we come back over here, we could actually add in some points to help us out. So for instance, this point right here, the coordinates of that point are 1, -4. And so if we use this rule, we'd find that on our new graph, our new point, keep the x the same, change the sign on the y. Well, the sign's already negative, so you're going to get +4. And so that would be one of the lines on the reflected graph. So if we go 1 and up 4, we get a point here. And so you see that we're reflecting it. The line of symmetry is along the x-axis, and so they're equidistant. So from the x-axis, it's 4 down, 4 up. And you could do that with the other points too, just using symmetry. You could check the points for accuracy if you wanted to using this rule. But you'd get a graph that looks something like that. So our new graph, if you change the sign of this point here, you have the x-coordinate is 3 and the y-coordinate is 0, but you can't sign 0, so you get a point there. So we could just keep going. We're just reflecting across the x-axis and then connect those red dots to get the reflected line. So this here is f of x, and sometimes what we'll do is we'll call it prime, because that's your translated or your reflected graph in red.